Hello everyone. In the last lecture you learnt about categorical and numerical data types. But I told you there was a second way to classify data types, and led us to see them as either being discrete or continuous data types. Discrete data. Let's start off with discrete data types. A discrete data type contains values that have a definite minimum size. They cannot be further subdivided. A classic example is just the roll of a die. Now, if it's a 6-sided die, it can either be 1, 2, 3, 4, 5, or 6 face up. It cannot land with 1.5, so that is a discrete value. Those are discrete values. Discrete of all the possibilities are finite. I can count them. 1, 2, 3, 4, 5, and 6. Continuous data. Continuous data is data that can take any value. Height, weight, temperature, and length are all examples of continuous data. Some continuous data will change over time. The weight of a baby in its first year, or the temperature in a room throughout the day. Continuous data is a type of numerical data that refers to the unspecified number of possible measurements between two realistic points. Continuous data is all about accuracy. Variables in these data sets often carry decimal points, with the number to the right stretched out as far as possible. Let's look at systolic blood pressure. If we had a blood pressure cuff and your data says 120 millimeters of mercury, but I can have a better cuff that can tell me it's 120.5. What, theoretically, I could even have a better piece of equipment that could tell me it was 120.555673254. That really just depends on how good my piece of apparatus is. So systolic blood pressure type would be a continuous data type. In this section, you learned about different data types like categorical and numerical data types, discrete and continuous. In the next section, you will learn about the basics of measure of central tendency and its types.